why am I so excited about OpenAI? Well, one thing about OpenAI is that it essentially promises a lot. Well, what it really promises is that it's a huge language model. It's largest language model that has been released to the market so far. And that's the reason why they wanted to have it so large is mainly because the creators of OpenAI wanted to make this model do something that's called a few-shot learning or zero-shot learning. So this few-shot learning is a technology that is used to reusing pre-existing language models for new tasks. And that is something that we've been working with when we were developing our tool for commenting source code. I will show you how it works. But OpenAI is about zero-shot learning. So using exactly the same deep learning model for a completely new task without any kind of pre-training for that task. Now, whether that is true or not, we'll see. But let's go and take a look at what this few-shot learning works. So to get an understanding, I mean, it works on natural language processing, but deep down, it's a neural network. So it uses vectors of words and how the vectors are positioned next to each other in order to understand the natural language. That's exactly the same kind of technology that we have used, for example, for the Acora tool in the Software Center for understanding source code and for making comments about the source code. Now, how it is usually done is that those vectors are huge, and the larger the vectors, the better the model. But the larger the vector, the more data it needs to learn. So things that have been done so far in natural language processing is reusing the model. So BERT is a language model from Google, which has been often pre-trained for natural language tasks. So it can understand natural language like English sentences. It's been trained on Wikipedia articles, some books, and so on. But it's a neural network model that we need to train to something specific. For example, if you want it to understand programming language, we have to take that model and train it a bit more just on programming language in order for it to understand programming language and so on. Now, this is very good, but it requires huge amounts of memory. So having a laptop is probably a no-go for that, although you can get some results. But of course, you have to have a large corpora of programs and comments or whatever you need for this program to actually work. So Codex is essentially something that doesn't do that, doesn't require us to have any kind of after training. So it's already been trained. So let's go and see how that works. So OpenAI as a model has a possibility to interact and test things with it on it using a web user interface, and that's what I'm going to do for the first task. So what I will try to do is something that comes with from the example from OpenAI. So I would like OpenAI to create a program that will do this. So this is something that 3 type of steps. I mean, create a list of first names, last names, combine them randomly into a list of 100 full names. And if I click on generate the program, OpenAI will most probably create a program in a moment that does just this. So it's a Python program. If I wanted to, I would probably compile that in a Python. But let's say that if I want to say check names are female, see what's going to happen. So if I do this, you see it added something here, right? So of course it's checking if the names are female and so on. Now, as you see, the way it checks whether a name is female or male is not really great, right? So it checks if the letter A is in the name, and if the letter A is in the name, then the code basically treats that as a female name. So it can create code, but if you think about this from a perspective of a programmer, you still need to understand what the program does in order to be able to judge if it does the right thing, or if you would yourself do this in the same way. So, of course, this is quite a cool way of interacting with AI, but it also means that it's not going to replace us programmers. But it's a simple thing. So let me check another test, perform another test that I would like to do. So say that we want to create those names in a database. So to avoid problems, I prepared this text beforehand. So this is basically the same thing, but I also want to check the names in the database, see what that's going to happen. And I use DaVinci CodeX to do this. Now it takes a bit of a model, it has to go to the US and come back. But it actually does something, right? So I was there before, instead of printing the names, now somehow it doesn't print them, but creates a database somewhere and then stores those names. Now, as you see, it doesn't do everything, it stops somewhere in the middle, and that's simply because my response length is about 300, or it's about 400 tokens, right? So could make it a bit longer and see what happens. But it can generate programs, right? So in this sense, it created a list of names, checked which ones are females, and then created a database, whatever kind of database, and then created connection, and then inserted those names in the database. Now, sounds like a really cool name, but you would say, okay, it's Python, it's a very simple task. So I actually tried it as well on a bit different task, right? So I actually thought about this at the very beginning when I was thinking about my students. So I have an OpenAI, and I'm giving them tasks to write programs in C and C++ at the beginning of the course. They are learning how to work with embedded software development. So I give them those tasks, and how do I know that they actually did those tasks, right? So I did give a try to a few of the tasks that you can find on the internet, for example, in the Rosetta code. So for instance, creating a random number, finding if the number is prime, and if it's prime, printing it and saving that to the file. So let's see if OpenAI can generate this kind of thing. Well, if you look at the code, I'm not going to read all of that, but it generally checks if the number is prime, right? Then, of course, as you see, it does some other things, which shouldn't really be there, because, I don't know why it calculates max, but it does it. This shows also how OpenAI essentially understands the code. So it wasn't trained on examples provided by humans. It was trained on the corpus of tokens coming from Wikipedia, from open books, from internet articles, to understand the English language. Then it was also trained on all the corpora of the GitHub repositories. And what it essentially does is, some point, it finds what kind of programs have been written in GitHub to find what would the next token be. And for some reason, people who are using prime numbers, they quite often use this kind of code, which is roughly checking if a number is smaller than some sort of max. Right? So this is what it basically does. Now, one other thing that I would like to essentially check as well is the fact that in OpenAI, or this kind of tasks, the whole idea, the first big use case for this tool has been to use it as a copilot. So some of you may have heard the term GitHub Copilot. It's a tool that is used for code completion or automated software development using DaVinci CodeX or OpenAI CodeX at the bottom. So that, of course, doesn't mean that you have to log into this playground, but you have to use that in other type of tools. So one of those tools is, of course, Python API. So let me change the screen for a second. So instead of going and logging to the website, I can use Python to interact with that, right? So first thing that I have to do is of course start it up. Now the starting up is a special way. You have to send a prompt, this is a test, to it, and then you get the response. And then as a response, you always get something. In this case, a random number, a random thing, this kind of text, which just shows that we can get a connection to that. One of the things that OpenAI has been marketed to do very well is to fix errors in programs. One of the cases, for example, fixing errors in Python code. So here I have this code that is also taken essentially from their tutorial, just to check if it works. So I'll tell the program that OpenAI that should fix the code, and this is the code to fix. I'm using the engine and some other parameters that I won't go into today, but essentially I'm providing the task as part of the prompt to the OpenAI. And that is something that is a bit different compared to the other deep learning models, in the essence that it's getting it closer to something that's called general AI, artificial general intelligence, that I'm telling the model what to do without essentially creating a specific model for that particular task. So here I'm telling this to fix this code. Now sometimes it works very well, sometimes a bit less. Now this piece of code, you see, I made one mistake over here. In this piece of code, I made 2 mistakes. But essentially, it could only fix one of those. So we could understand that Panda and Pandora are quite different things, and it didn't catch the fact that I actually make a mistake in that part of the code. So, but all of that I've showed you was in Python. So let's see if it could actually do something in with the actual C code. So let's imagine that I create a C code and I have a compile error. And those of you who know C, semicolon, of course, I've forgotten that in my program. So let's ask OpenAI to fix this. Well, okay, I got something, but it's not really complete. Now, why isn't it complete? Well, it isn't complete because I haven't told OpenAI or the model how many tokens I want to have back. The reason why they took it, I think it's 16 tokens as the default. And the reason why there's 16 tokens is because the business model behind OpenAI is that every request I'm sending and every response I'm getting charged for. So I think I got $18 to start with. I think one token costs 0.01 cent. So I'm pretty good. I think I have money to test that today, but it costs, so to say. So if I want to get a better response, I have to increase this parameter max tokens. So let's see if I do it, what kind of response I get. Well, now you see that essentially it could fix that mistake. You see there is a semicolon. And it could actually fix another mistake, so it could return a 0, right? So my void main void should actually be int main void, main void. It should be like this. So you see, I'm getting this kind of response. Again, I'm fixing the code. Now, another task that I could do is I could actually transform the code from one programming language to another one, right? Could do something like this. Transform printf from C to Python. I could ask it. So you see, this is how a Python code would look like, Python 3 code. Then I could even try to do the same thing as I did at the very beginning, but with Python. Instead of Python, I could use C. So I could do this prompt and see how that essentially works out. And as you see, I'm getting the response. Now, those of you who program in C, C++ see that this is not really C that I'm getting. I'm actually getting C++. But what I'm getting is a kind of okay code. I don't think any random generation of the names, but it does generate some sort of names somewhere. So technically it's okay. So again, if you want to use it for your programming tasks, you could use it, but you better know what you're doing, because it's probably not going to solve all the problems for you. Now, to test another thing, I've used a text. So I went to rosettacode.org, which is a website where you can have a lot of code that solves typical programming tasks, like, for example, here taking a factorial of a number. So I took this description exactly as it is in Rosetta code, and I say I want to have a code in C. And the CodeX should give me pretty good code doing just that, right? So it's the essence of that is, of course, the factorial function, which it could write from scratch. But then I was thinking, in our software center project, what we are doing is we are trying to make comments to the code. So commenting the code in the continuous code reviews. Now, I was thinking, can I use that task for this? Yes, I could, but I didn't have a good idea of how to do it. So what I tried to do is try to generate a description of what the code actually does, which is, by the way, quite often one of the first comments that reviewers write in code reviews, asking what does this code really do? So if I ask the code, if I take the code, roughly part of that, the C code from the Rosetta code that I got, and I ask to write me an elaborative high quality DOS string for the above function, and see what I really get. Okay, it could actually describe this function pretty well, right? Without knowing what this function does. You see, the code it got was a raw C code. Okay, the name of the function could make a difference here, but you see, I could get some understanding of what the code really does. So then I was thinking, okay, if this codex can do this, how about I take some part of the code that we wrote for our tool for commenting codes, and I just do the same thing, right? So this is a code that tokenizes some sort of strings in a specific way. And I'm asking it to give me the comment, right? Nice. It could actually do that, understand about tokenization. So it could understand natural language. Then how about I say, okay, maybe there is a better way to write this function. So I've asked this codex as the last thing to basically tell me how you would have written this code. And you see, well, it's even simpler than what we used for that. Essentially not really exactly true, because our function is used somewhere else, but in a different context. But as you see, could give us some sort of examples of what we can and cannot do. Now I have 7 more minutes, and before we go towards the end of that, I will open up for questions. I would like to show you one other thing. So Codex is for coding, but in Software Center, in the next sprint, we will try to use Codex or a model based on Codex in a few use cases. So one use case is we're going to use it to check the quality of the code written by different companies. Some of the companies were kind enough to tell us which kind of open source repositories they are using, so that we don't end up in using proprietary code when testing that. But coding is one thing. We also want to use OpenAI for requirements. So let me check if OpenAI can actually write a requirement for us. So I want to create a requirement. Say I want to say that I want to connect with a mobile phone. I'm changing the model because the models here are essentially trained. This is something that's called a few shot example, right? So they're not exactly completely open for any kind of task, but just for a task that they are using for this. So let me say, how about if I write a requirement, something like that? Your mobile should be off and you drive. And just say, how about, you know, this OpenAI generates some sort of requirement that is not more than 200 tokens. Okay, it doesn't understand it's a requirement. It doesn't understand what kind of text it is. It generates something like that, right? We could dive into this, but as you see, kind of use could be like a requirement to some extent. It has added this one. Again, as it doesn't understand that it's a requirement, it cannot tell us exactly what we should write. But in Software Center, we want to use that to create some sort of idea of requirements based on real requirements from some of the companies. And we'll feed them into this OpenAI playground and see what we get out of that system. Does it resemble requirements in a good way? What we're also going to do in the reporting workshop, we're going to have some sort of task related to hacking a server, finding security threats. And today in the coordination team meeting, we were discussing what this hackathon would be. So I've asked OpenAI to generate a sequence of words that will describe this hackathon. So maybe I make it more than 200 words. Try to generate. So our hackathon will be about hacking a server, technically. Let's see what OpenAI would suggest for this. It takes some time because it's a lot of tokens. Yeah, and it does complete the text. I mean, it of course adds a lot of more things that I would like to see, but yeah, this is roughly about that text. Now,